Hello, everyone. I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Scratches by a Parliament of Owls. Owl, that's kind of appropriate, right? You have a Parliament of Owls, you'll definitely have scratches where they sort of hang on to wherever the bar is where they are. Um, I like the name actually, a Parliament of Owls. It's sort of it brings forth a mind, like to your imagination, a very interesting scene. Um, I guess I've never done any puzzle by this setter, so I mean because I think I would have commented on the name before. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means every row, column, and marked region in the puzzle must contain the digits 1 through 9 at least once. Wait, so then um that's interesting. That's an interesting formulation. I mean, you can extend that, so that is potentially extendable. So, um yeah, I mean that's fine. Um Anyways, let's get to the additional rules. It's just normal Sudoku rules, so just keep that in mind. We have additional rules. We have region sum lines, where digits on the blue line must have the same sum in every box they pass through. Digits on equal sum lines may repeat if allowed by other rules. If a line enters a box multiple times, every separate part of the line must add to the sum. So the way I like this uh, rule set being phrased is um, box borders divide the region sum line into segments which must have the same sum, right? So basically that means this segment must equal the same sum as these segment, which must equal the same sum as this segment, which must equal the same sum as this segment, right? So it's a little bit more concise way of putting it, but you know the way that he states, or he or she states it, it's a parliament. The way that they state it, then, would be that is perfectly fine. But as an example, you could have something like, say, let's use this small one as an example. You could have 3 and 5, and therefore this would be 8, because the sum of the digits on this segment, which is 3 and 5, add up to 8, and the sum of 8 obviously adds up to 8. So that's an example of how region sum lines work. We have little killer, where digits on marked diagonals must sum to the number provided outside the grid. So for example, these digits here along this diagonal must add up to 42. These digits here must add up to 19. So you could have something like, say, 5, 6, and not there, 8 here. And this would satisfy this little killer clue because 5, 6, and 8 add up to 19, which is the number that's outside of the grid where the arrow is coming from. And that's an example of how little killer works. And finally, we have thermo, where digits on a thermos rise from the bulb end. So it basically just means that this digit is smaller than that. So say anything like 4 and 7 or something along those lines works. So that's an example of how thermos work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. So, we have some region sum lines, which is 1 digit on one segment and 3 digits, 3 unique digits on another segment. This is at least 1, 3, and 4, because it can't be 2 because of the 2 in the box. So this must be either 8 or 9 to add up to that, right? 1, 3, 4 adds up to 8 at minimum. And then you could also have 9 there. So this is 8 or 9. This is 8 or 9. We also have another region sum line where we have 3 unique digits on one segment and 1 on another. And this has to be then 2, 3, 4 at minimum, because we can't have 1 in that region's sum. So it's 2, 3, and 4, which guarantees this is a 9. So this must be 2, 3, and 4 to add up to 9, which is the maximum this digit can be, obviously. And this is the minimum amount for that. That's the reason why we know this is 9 and this is 2, 3, and 4. Because if you try to make this larger, the problem is that's not going to be a digit then, which is not possible. We also have another sum which adds up to, which is 3 unique digits and a single digit. And this cannot be 9 here, so this is 6, 7, or 8, which means this is either 1, 2, 3, 1, 2, 4, 1, 2, 5, or 1, 3, 4, which you guarantee the 1 has to be one of these 3 digits. This cannot be 2 because of 2 in the column. This can't be 5 because of 5 in the column. And we know these 3 digits add up to 19. Well, 1 with 2 other unique digits can never add up to 19, right? Because it adds up to, at most, 1 plus 8 plus 9, which is 18. So this cannot be 1. If it's 2 here, this has to be then 8 and 9. So therefore, this would be 8 and 9 here. If this is 3, this would then be 7 and 9 to add up to 19. And so this would be 7 and that would be 9. If this is 4, though, we could have 4, 6, 9 or 4, 7, 8. So this is 6, 7, or 8 with a 9, or this could be a 7, 8 here, right? 4, 7, and 8 adds up to 19, or 4, 6, 9 adds up to 19. So either way, this is guaranteed 2, 3, or 4. 1 has to be one of these 2 digits here. And again, it can't be 5 because of 5 in the column, so you can't have 5 with other digits adding up to 19 here. Okay. Do we have anything else here? The remaining digits in the central box cannot be 1, 2, 3, 4 because of the 2, 3, 4 triplet in the box. So this must be 5 through 9. And this can't be 5, and this can't be 9. So we're guaranteed in the central box a 5 in one of these 2 cells. This must have it must be either 1, 3, 4 or 1, 3, 5 to add up to 8 or 9. So this is guaranteed to have 1 and 3 here, which means the remaining digits in this box must be 4 through 9 as possibilities. Okay. These digits, we don't have very much information there. This is 9. So this has to be 9 here, because this is also one unique digit as a segment. So this is 9, which forces this to be 8, which means this cannot be 8 or 9. This can't be 8. This can't be 8. Where is the 9 in the central box? It has to be in the central cell, because that's the only place it can be now. So this must be then 1, 3, and 4 adding up to 8. So the remaining digits in that box then are 5 through 9. And this can't be 5, and this digit must be greater than that. So this can't be 5 or 6. That leaves this not being 9, because 9 would be greater than any digit that would be there. So we have 6, 7, 8, 9 there. This is 5 through 9 there. So this is 8, which means this is 8. These 2 digits add up to 8, so it's either 1, 7, 2, 6, or 3, 5. 1 can't be here, so 7 can't be here, because if this is a 7, that would force a 1 there. This can't be 2, so this can't be 6. 8 cannot be either of these cells because of 8 in the row. This can't be 9 because of 9 in the column. So this is 5, 6, or 7 that these two digits add up to. Okay. These two digits add up to the same. Okay, so this is 6 or 7. So we can't, this has to be 1 and 2 with 3 or 4. So we're guaranteed in this box there is a 1 and a 2 here. Well, we know these sum up to the same sum as these, and this sums up to the same sum as this. So that means if you sum up these three digits, that equals the same as summing up this and this, right? These three match this cell, and these three match these two cells. So if you add these three together, they equal exactly the same as these 6. Which means this, essentially along this large diagonal here, the long diagonal, this is equal, 2 times these 3 digits is equal to 42. Well, 42 divided by 2 is 21, so this must add up to 21, and you cannot, it has to be 5, 7, and 9. Right? Because it cannot be 6, 7, 9. 6, 7, 9 adds up to 22. Cannot be 5, 6, 9. That adds up to 20. So therefore, this must be 5, 7, and 9, which makes this 6. So this must be 1, 2, and 4, adding up to 7. So there's no 3 here. Okay. This is 2, 3, 4. This adds up to 9, and it cannot have 1, 2, and 4, so it must be a 3, 6 pair. So this is 3 and 6, which means this can never be 6 here. So either this is 2, 8, 9, or 4, 7, 8. Either way, one of these is guaranteed to be an 8. Remaining digits then in this box are 5, 7, 8, 9 because of the 1, 2, 4 triplet and the 3, 6 pair. And this can't be 5, so it's 7, 8, and 9, which leaves 5 only being here. And this can't be 8, again, because we know one of these two is 8. It's either 2, 8, 9, or 4, 7, 8, adding up to 19 here. Okay. This adds up to 14. It's not very restrictive right now, so we won't look at that right now. 5 eliminates 5 from being here. Where is 5 in this upper right-hand box then? Can't be here because of the way the thermo works. It must be greater than this digit, which is 5 cannot be, so it has to be here. So this is 5, which eliminates 5 from being here, which means this can't be 3 to add up to 8 with that. This adds up to 6 or 7, so we have guaranteed 1 through 6 here. No 2 or 5, no 1 here. So this can't be 6, because if this were 6, that would be 2 and 6 at minimum, adding up to 8, which is not allowed. So we have 1, 3, or 4 there. This adds up to 14, this adds up to 9. This is 7 or 8. We don't know which. Okay. 5 cannot be here or here. 5 cannot be here or here. Five has to be one of these 3. This adds up to 45. Okay. So since this adds up to 45, what is the maximum this can be with 5 and 9 here? I think it has to be 45. 24 is 789 is the max for 3 unique digits, but this is only 5 and 9. Oh, that's not true. Okay. So we have 24 here, which means this must be at least 21. Okay, well, there we go. So this is at least 21. And this can't be 8 or 9, so this is at most 7. 5, 7, and 9 at maximum adds up to 21. So 5 and 9 with 7 being the maximum adds up to 21. And the maximum here is 24, so therefore the maximum along this diagonal is 45. So it must be the maximum. So this has to be 7, which means this can't be 7 here. And these have to be 7, 8, and 9. And this can't be 7 or 8 because of 7 and 8 in the column. Therefore, this is 9, which means this can't be 9. That's 8, which makes this 7, 4, and 8 to add up to 19. 4 eliminates 4 here, so it's 1 and 2. This 7 eliminates 7 here, so it's 9. This can't be 7 or 9, so it must be the 8, which makes this the 7 to add up to 45 along this diagonal. So 7 eliminates 7 here. This 7 eliminates 7 here, so this is 6. Well, to add up to 6, now you can't have 3 anymore because it's 3 and 3 adding up. So this is 1 or 4 with 2 or 5 being here. 1 and 5 add up to 6, 4 and 2 add up to 6 there. 7 here eliminates 7 as a possibility here. So this can't be 1 and 7 anymore, adding up to 8. This 8 makes this have to be 8 because they must sum up to the same sum. This adds up to 7, so it's either 1, 6, 2, 5, or 3, 4. And this can't be 1, so this can't be 6. This can't be 4, 5, so this can't be 2 or 3. This must be 1, 7, 1, 7, 2, 6, or 3, 5. 5 can't be here because 5 in the row, so this can't be 3 there. Well, 1 eliminates 1 from being here. 4 eliminates 4 from being here. So we've used all the little killer clues. Remaining digits in column 7. We have 3, 4, and 8, then this can't be 8. So that makes this 3 or 4, which makes this an 8. 8 cannot be here anymore, so this is 9. And this can't be 6 or 9, it's 7. This can't be 6 or 7, it's 8. Where can 9 be in this upper central box? Can't be here or here because of 9's in the columns. Can't be here because of 9 in the row. And can't be here because of the region sum line. So it must be here. So this is 9. Where can 9 be in row 2 now? Can't be here because of 9's in the box. Can't be here because of 9 in the column. And it cannot be here because 9 plus another digit is never going to add up to 9. So this must be 9 here. Sorry, 9 plus another normal Sudoku digit cannot add up to 9. If you had zeros possible, then you could. But anyways, this has to be 9. We have 8 9s. We know where the last 9 has to be. It has to be there. So now look, it's 8. We have... Where can 8 be in this upper central box? Cannot be here or here because of 8's in the column. Can't be here or here because of 8's in the row. So that means that leaves that as 8. And we have 8 8's now. We know where the last 8 has to be. It has to be there. 7's. Where is a 7 in column 4? Can't be here because of 7's in the boxes. Can't be here because of the way that the region sum line works, and this is filled out, so this must be 7 here. Unfortunately, this can't be 7, so therefore this can't be 1, but that's not that helpful. We have a 2-5 pair in column 5, which eliminates 2 and 5 in the rest of the column. So this can't be 2, this can't be 5. Since this can't be 5, this can't be 2 to add up to 7 with that. Remaining digits in column 5 then are 3, 4, and 6. Okay. 7 has to be one of these two digits in row 2 because it cannot be here because of 7's in the boxes. We also have a 1, 3, 4, 6 quadruplet left in this upper central box. So it's 1, 3, 4, and 6, and we're guaranteed 1 or 4 has to be one of these 3 cells. That eliminates 1 and 4 in the rest of the column. This can't be 1. That forces this to be 3 and 4. That 3 eliminates 3 being here. So this is a 1, 4, 6 triplet. That eliminates 1 and 4 and 6 in the rest of the column. This can't be 3 or 4. It's 2, which eliminates 2 here. This 1, 4, 6 triplet. This can't be 6 because of the 6 in the row. So this is a 1, 4 pair, which eliminates 1 and 4 in the rest of the box. This can't be 1 or 4. It's 6. That eliminates 6 here. It's 3. 3 and 5 add up to 8, so that's 5, which makes this 2 and 4 and 1. 3 here eliminates 3 here, so that's 1. It also eliminates 3 here, so it's 4, which makes this 3. This can't be 3 or 4. It's 6. Remaining digit here in column 6 is a 5. Remaining digits in column 4 is 1 and 2, and this can't be 1 because of 1 in the row. So that leaves this as 2 and 1. This can no longer be 1 and 7 being there. This can't be 2 with 6 being there. And this 3 eliminates 3 here. So this must be 2 then, which makes this 6 to add up to 8. 6 eliminates 6 here, so it's 3, which makes that 6. This can't be 1 because of 1 in the row. So these two digits add up to 5 because we have 9 on this side, we have a 9 on that side. Those cancel, so the remaining digits here must add up to the 5 here. So this is 1 through 4, adding up to 5. This is 1 through 4. This can't be 1 or 2 because of 1 or 2 in the row, so this can't be 3 or 4. And this can't be 2 because of 2 in the column. So this must be then 1 and 4, which forces this not to be 4, so it's 3, which leaves just a 5 in the row. And that's 3 in the corner. We celebrate because we know we're close to solving it. This 3 eliminates 3 here, so it's 4 and 3. Remaining digits in row 3 are 2 and 3. And remaining digits in row 2 are 6 and 7. Okay, and we don't have any more information there. Remaining digits in column 9. We have 1 and 4. And 4 cannot be here because of 4 in the row, so that makes this a 1, which makes that 4. Remaining digits in column 8 are 2 and 6. 6 can't be here because of 6 in the row. So this is 2, which makes that 6. Remaining digits in row 4 are 2 and 4, and this can't be 4 because of 4 in the column, so this is 2, which makes this 4. 2 eliminates 2 here, so it's 3, which makes this 2. 2 and 7 add up to 9, so that's 7. This is 6. Remaining digits in row 6 are 1 and 5. This can't be 1 because of 1 in the column, so it's 5 and 1. And this is 2, 7, 5 here. This must then be 2, 7, and 5 to add up to the same sum. We have 1 and 6 here, which forces this to be 7 to add up to the same sum, and this must be 1 and 6. That leaves this as a 3. Remaining digit here is 4. Remaining digit here is 3. Remaining digit in row 9 is 1, and remaining digit in row 7 is a 5. And that's how you solve it. I'm usually not a big fan of region sum lines, but this puzzle does a very good job of highlighting how you can use those fairly well to get the solve through the puzzle, right? It flowed very well throughout. It was a nice flow throughout, and yeah, overall just a nice little puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.